Just testing the mic, testing 1, 2. Testing 1, 2. Alright, so this video is going to have like a 15-second to 20-second lag. Click to read or unread. Okay, so it's going to happen here. We're going to have a delay. So if you were to ask questions, I won't be able to see them till 15 seconds later, which is the cause of my internet out here where I'm located. So first of all, I know a lot of us are working Saturday, and well, our priority is to be with where the help is needed, and that's okay. But I want to leave this video online on the channel, where if you are interested in digging more into the NEC 2020, then maybe in your studies, hopefully this channel can help you grasp more information, and it's going to help you on your research for your answers. Alright, let's get started. Chapter 9 is a chapter where you're going to be really going back and forth, especially when it comes to conductors. Selection for pipe, different insulation type, and that is very important whenever you do go to take your test, your exam, for your journeymans, and also for masters. So again, this is my journey for my master. This is my channel, my journey to masters on the NEC. Sharing my journey to you in my channel, my personal studies, and reveal my knowledge to the NEC. And of course, there's many great electricians, engineers that are involved with the NEC, and they have great knowledge, which also helps to inform us and share information and knowledge to always give the customer, clients, the public a better installation. So that's our final goal, is to conduct electricity from one premises to the other, from the grid to a home where kids are playing at the other end, where business is being run safely, where it can handle the load of production safely. And that's our job as a qualified electrician, to provide that for our clients. So I've noticed throughout our installs, many of us have started, and we kind of start in a way where we're not learning much through our experience with other electricians. So we kind of jump in the middle of projects, in the middle of, you know, a job that's running behind, and we're there to hurry and get it installed and up and running. But also, I don't hold the copyrights to the material that I will be sharing. Of course, I will have my own edits. I would have my own, so slightly different numbers, but that's just to share the how to come up with the answer in your end whenever you go take an exam. Also, my channel does not support or meet practical safeguards of people or persons for electrical install. So my channel does not certify you. My channel does not qualify you to do electrical work, even though we will see electrical installs near future, stuff that I am involved with, of course with my own edit. But this does not mean that you're qualified to perform electrical work. In other words, you need to be supervised by a master electrician to safely teach and go over the installations to a qualified and well install for clients and people that are needing electricity. So if in my channel you see later on doing some install, that doesn't mean you know how to do it. It's just my story, my journey. I'm sharing it, and again, it does not certify you as an electrician. You need to follow the proper channels for becoming qualified to do safe practices. Alright, so chapter 9. I will be sharing my screens, and bear with me, I have a remote camera where it's showing the material that I will be going over. And so I'm going to be pulling up the 2017 NFPA or the code book, where chapter 9 has not have much changes, but we're able to see the numbers. And again, if there is any code changes that from the 2020 2017, I will try my best not to post it, and I'll just probably show you my personal code book, the way I write on it, the way I'm approaching for my exam for the masters. So you will be seeing some views from the 2017, but again, it's just tables. Tables haven't changed much on chapter 9. So here we go. So here I am sharing. Let me go back to, bear with me, this is my first video or live with the public, so it'll be a little bit slow. So chapter 9, it shows us, this is the last, towards the end of our code book. And again, in my videos, we're not going to be going over page numbers much. I might reference a page here and there, but in the NEC, we gotta understand the language that it uses, which is, like for example, here in this area where it says 310.15B3A for adjustment factors. So it doesn't give you page numbers. So this is another approach how to use this book, the NFPA 70E. Well, the NFPA 70. And it's going to go by chapters, articles, tables. So that's what the language we're going to have to get used to if we're going to practice the electrical installations. And also, authority having jurisdiction will ask you any code references through these. They're not going to approach it through page numbers. So just a quick also introduction that I want you to see and pay attention to. It's here, Article 90. So you can be tested in Article 90 introduction. Also, they might throw a question here and there on your journeymans. So it's just best to start getting familiar. Okay, so again, I did note that I am reviewing certain things on the 2017 edition. But let's just read here. This hasn't changed either. So 90.1 says, practical safeguards. The purpose of this code book is the practical safeguards of persons and properties from hazards arising from the use of electricity. This code is not intended as a design specification or an instruction manual for untrained persons. So again, if you need to be trained and want to be in the electrical field, you need to follow the channel of registering with the Texas department if you're in Texas, or your license registrations in your state. And once you get your apprentice license, you can go apply as an electrician under a master. A master is responsible the way you are trained, the way you perform installs in the field, and also teaching practical safeguards. As we see here, practical safeguards persons. So again, we're just trying to conduct electricity from one property to the other safely without rising any hazards. Okay, so well, here's an informational note. Informational note is not a requirement, it's just informational. if you see here, let me try to zoom in more because I know in your phone it might, if you're looking at this on your phone, it might be small. So, informational note. When it says informational note on the code book, it's just information. So you might get a question there if it's a requirement for an install. No, it's just an informational note. It's just for your information. And we get that the continuous load is an informational note. Also, what's the other one? 3 to 5% on your service entrance is also an informational note. So we do use that once in a while, but not much. But as a service entrance for calculations from the meter to your last outlet, it's a 3% for the whole service, and it's a 5% for calculations. So here it says hazards often occur because of overloading of wiring systems by methods or usage not in conformity with this code. We've seen that a lot. A lot of machineries, especially in industrial, where they just try to piggyback on existing circuits, or they just tie into existing circuits without knowing what's the power behind it, I guess the install, and conducting safely the power or the amperage that the equipment is using at the end. Okay, this occurs because initial wiring did not provide for increases in the use of electricity. So again, just because we see a circuit, it doesn't mean that we can use it for what we're needing it. We have to do our math. We have to consider the length of the wire, the overcurrent protection device, OCPD, which a short word is a breaker, or fuses, or anything that is a current protection device, a starter, and initial adequate installations and reasonable provisions for the system changes provide for future increase in the use of electricity. So we do see a lot of equipment. It's being sent out and updated with newer, which the newer I always most of my time I've seen that they are more efficient, which I do like because we're starting to have drives and stuff like that. Oops. So again, let me go back to 90. Okay, so let's see here really quick. You will, in your journeymans, also see they might try to confuse you or ask you a question if you can do install on the ship. Or it could just ask you for information on Article 90.2 A and B. Again, our language is the number here. This number here is 90.2, and then we go to A or B. It's covered, not covered. So you have to embed it in your head. The way you understand this book is by articles. 90.2, A or B. So here, let's just zoom in a bit more. Too close, maybe. Okay, 90.2 A, covered. This code covers the installation and removal of electrical conductors, equipment, and raceways, signaling and communication conductors, equipment and raceways, and optical fiber cables and raceways for the following. And here you go. Public and private premises, including building structures, mobile homes, recreational vehicles, and floating buildings, marinas. 2. Yard, lots, parking lots, carnivals, and industrial substations. Even though industrial substations, you would have to get extra training for that. So you just can't walk in there and think you are okay knowing the hazards. So it's just best to always have the proper training for that, and also someone that's going to be able to conduct you there safely. 3. Install of conductors and equipment that connect to the supply of electricity. That's mostly what we do. Installations used by the electric utility, such as office building, warehouses, garages, machine shops, and recreational buildings that are not an internal part of a generating plant, substations, or control centers. Again, like I said earlier, in the industrial substations, you could see generating plants also as part of it. So that's a fine line in how to interpret this area here. Substations and control centers. When you hear control centers, don't just think of a control cabinet. There are buildings where it's just nothing but control centers on the premises. They're just controlling medium voltage and starters, so you will see that. Okay, this is where I do want to want you guys to pay attention to. In Article 90, Article 90 says point 1. Okay, Article 90.2 B, not covered. This code does not cover the following. Okay, so number 1, installations in ships, watercraft other than floating buildings, other than marinas, remember? Railways, rolling stocks, aircrafts, and automotive vehicles, and other than mobile homes and recreational vehicles. Informational note, here we go again. This is just for your information. Remember, get familiar with this note here. It can help you in the long way. But again, it's not demanding it for you to install it this way. It's just for your information. Although the scope of this code indicates that the code does not cover installations in ships, portions of this code are incorporated by reference into Title 46, Code of the Federal Regulations, Part 110 through 113. So what this means that this code book is not just excluded in their installs, but they do have different approach in how they install in those boats or big ships. So it's integrated with other codes that are needed to be enforced also. So again, this is just for not covered. So in your journeymans, if you see, if it asks you questions to see where, like a red flag would be a railway station, or let's just see here. Where did I see that? Okay, ships. So code does not cover installations in ships. So I've seen that question once in my journeymans to see if the NEC covers installations on ships, and my answer was no. So this book does not cover. Again, it says here not covered. So this code book does not cover the following, and that's where you see all this information. Okay, so let's go back. I just want you to get familiar with Article 90. Again, this is how we're going to learn the code. Okay, let's go back to the YouTube share. Okay, so here, Chapter 9. This table here is going to be really involved for the rest of your career as an electrician, as a designer for conduit layouts, or as a lead man. You can be an apprentice and you will be involved with this table. So let's get this zoomed in. Okay, table 1, percent of cross-sectional of conduit and tubing for conductors and cables. So here we automatically get the percentage cross-sectional area. this here. We're going to see that here in the later calculations. Number of conductors or cables. So, example of cables, it could be control wire, where you have a pair of wires inside of it. That's a cable. Conductors could be THHN, THWN, number 14. Anything that's, to me, it's kind of singled out. Cables, in my interpretations, is we're going to look at a cable with the CSA. So when you do order cable for your projects, it's good to pay attention to the CSA of your cable. The CSA is going to help you determine the cable, the conduit size. Let's just say you got 100 feet of conduit that you need to run, and you got 10 cables. Then what's the size of conduit you're going to need? You can split it in two and go half, but again, how do you do the takeoff? So it's good to know the CSA of that cable. That cable can have two pairs, it could be just one pair, or it could be multiple pairs. Who knows? You just the important part is the cross-sectional area, the percentage. So you will have, let's just say you have, for example, on this one here, the 53%. This was good. So I've seen it a lot in electrical rooms where you have a PVC. Let me see, equipment, ground conductor. Let's see if we can single one out. Okay, here we go. Just make sure you can see it on your screen. Let's just do another one so you can see more of a better example of what I'm talking about. Okay, so here's a good one. Let me just zoom in. So let's just say we're needing to, where is that image? Let's go back. Let's just say here's a transformer, and we're going to run an equipment ground, a ground wire for our bond to building steel. Let's say our metal is up here in the rafters, and we're wanting to bring that cable down and bring it into the transformer and bond it to building steel. So a lot of the practice I've seen is they run a PVC up to the rafter just as a sleeve, where we can kind of dress up the conductor, and then they kind of stop midpoint. Or it could be a rigid conduit where we have threaded ends and we'll bond the pipe with the wire and then land it on a transformer inside. Well, that conduit fill, it's also for this here. 1. Cross-sectional area, number of conductors. So it's asking you for number 1 at 53% fill. Okay, so let's move on. So we got the understanding of 1, 2 cables, 31%, and this is the other one that we mostly use daily, the 40% fill. And you're saying, well, I don't see the 60% fill yet. We will introduce that here further in the table. So over 2, 40% fill. That's the standard that we use whenever we do more than 24 inches. Then we jump to the 40% fill. Remember, we're in chapter 9, table 1, over 2, 40% fill. Again, informational note number 1. Table 1 is based on common conditions and proper cabling and alignment of conductors where the length of the pole and the number of bends are within reasonable limits. It should be recognized that for certain conditions and larger size conduit is lesser conduit fill should be considered. Okay, so here we've seen this many times. Even journeymen do the same mistake, even supervisors, where they make a call, hey, let's run 400 feet of pipe without a box or a way to have, it's just too long. There's no access point to, if we need to send a fish tape through the pipe to pull some jet line or any rope. That this is a problem that we run into, and trust me, we lose a lot of time in the field for this, all because we don't have enough pull points or an access where we can continue to send that fish tape down the pipe. One thing that I do recommend, if you don't, let's say you're on rafters in commercial and you're running a 2-inch pipe along the rafters, let's just say you're getting above 150 feet. Usually the rule is, over 100 feet, we start paying attention where to set our J boxes. But again, what if this is underground? Well, that's a good question there, because sometimes underground can exceed 200 feet. So again, if there is a way that we can secure the install and it's more than 200 feet, then we have to give a proper install, or you could just start feeding a jet line while you're running your pipe, if that's one of your concerns, and avoid having any trash inside of the pipe, because we can run into difficulties later in having something damaging the cable while it's being pulled. But in this example that I'm giving is an existing building overhead and rafters. I would consider points where you can have access to, and just in case if you have to send a fish tape further down the conduit, then you're able to do so without losing so much time and breaking couplings apart just because you don't have a fish tape that's long enough. And also, if you use vacuum, you will have a lot of leaks in vacuum with the bag if you have the set screw couplings. So if that is your plan to take off with this conduit, that's a long shot. We got to make sure that we seal off all the potential leaks on those couplings, especially set screws. It will not work too well. So that's just one thing you might want to consider. Set screw versus compression couplings is compression will give you a better seal. And also, if you're doing underground, make sure you don't have nothing that's unconnected and you're going to have a leak or anything of that nature where it's going to hinder your seal for the vacuum. Okay. Informational note 2. When pulling 3 conductors or cables into a raceway, if the ratio of the raceway inside diameter or the conductor or cable outside diameter is between 2.8 to 3.2, jamming can occur. It's just letting you know, hey, if you do select the conduit and the ratio is 3 to 2 or 2 to 8, between 2.8 and 3.2, then the potential is you will damage that wire. Again, when you start pulling pipe, let me change the screen. So if you do start pulling wire with a tugger, you have to remember that all those wires are trying to be flat in every 90. So as your wires are coming up to that 90, they're all going to try to flatten themselves and continue on with the tension you have by pulling your wire. So it's one thing that we really need to consider, where we locate our pull boxes, how much wire are we pulling, and the pipe fill. So let's go back to the table. So note to tables. Again, these are going to be your notes, which gives us the ability to use the 24-inch nipple and a 60% fill for that nipple. Okay, so informational, let's start with note 1. See informational in Annex C. Okay, this is where I wanted to touch base today. This one and different installation types. See information Annex C. So Annex C would be, look it up. Here it is. So Annex C, C1 through C13, gives us a list where these tables is used in conjunction with table C1 through C13. The conductors installed must be of the compact type. Okay, the asterisk C. You see this little star looking thing? If you got compact wire, this is the table that you want to see for that. Only if your installation is all the same type. Let's just say I got THHN, just regular THHN, and I have some cable that are compact type. Let's go back to chapter 9. Say Annex C for maximum number of cross-section for conductors and fixture wires. All of the same size. So this has, if you want to use Annex C for conductor count on your pipe, then they must all have the same size. Total cross-sectional area including insulation. So CSA needs to be the same, including insulation type. Permitted in tray size for applicable conduit or tubing. So let's just say we have panels that are all number 12 THHN. They're all the same installation, they're all the same size, and we're using this just for branch circuits. And you want to take off, then you are allowed to use Annex C. Or let's just say an example. Let's go to that example really quick. So let's just say we are using under EMT, or we could be using PVC. We got both Schedule 40, which is the standard size we use, or Schedule 80. Sorry. So Schedule 80 is usually used whenever we do a rise for the service, for encore up on the pole, or anything that is a fuel requirement on the specs on the job. So Schedule 80 can handle more weight if it's being crushed by, or if you want to run temporary PVC exposed over ground and you have a bunch of construction vehicles going over. Of course, we protect the Schedule 80 with some wood, kind of like a ramp to go over it, but you can put a Schedule 80 on the ground as temporary and still add protection to it. So Schedule 80 is a good option. It's just a bit more expensive, but just for you to know. Now Schedule 40 is the standard that we use underground a lot. Okay, so if we want to see how much wires with the same size, the same insulation, then we can use this Annex C. So here a bunch of us use electrical metallic tubing, so we go to page 718, and that's just for this table, 718. Okay, so here it is. So let's just say THHN, let's look at, if you notice, we see this blank. Or you're trying to use number 12. All these here are your insulation type. SF, PF, PFF. So again, in your test, you could see these letters. They just want you to choose a proper table like C1, and then the type. This is the type you're looking for: XHHW, XHHW-2. So you're probably asking yourself, what is the difference between XHHW and XHHW-2? XHHW and -2 allows you to go to 90 Celsius, and it's waterproof, water resistant. Let's see this one here. It's for wet locations. Now, as we know, everything that's considered outside, especially underground, is considered wet locations. So THHN number 12, we use that a lot. Number 10 and number 8. Trade size conduit. So I do want you to forget here for the States, if you're here in America, we don't use metric or this number here. The 12, 16, 21, 27, all that in parentheses. We don't use that. We use this trade size number, the trade size, not the metric. Everything in parentheses here is metric. We don't use metric. We're in America. Trade size. So now let's say for a 1-inch conduit. Can you imagine learning all these numbers? 27. Give me a 27 metric conduit, or 35. Sounds weird. Anyways, let's say a 1-inch conduit. How many number 12s can we fit in a 1-inch conduit for EMT? Okay. So a 1-inch conduit, THHN, we can fit 35. 35 conductors. For number 14, 35. For number 12, we can fit 26. For number 10, we can fit 16. That is including your equipment grounding conductor. You remember your equipment grounding conductor, you count it once. And we'll see that later in our channel. When you do box and stuff like that with more than one grounding conductor. Oh, anyway, so how many, let's say you get a question, same insulation, same size, everything's the same on the conductors, and they ask you how many can you fit on a 1-inch. You are safe to go to the NEC. Well, you'll see number 10, you can fit 16. Or let's just go further higher. Let's go for a 3-inch conduit, EMT. Remember, we are under EMT right here. C1, electrical metallic tubing, EMT. You got to pay attention to this. If you don't, then you will. It will bite you back. So THHN or THWN or THWN-2. All these three you can safely use in this section. In this whole section here. Everything that's highlighted. That. So let's say number 6. How many number 6 THWN can I fit in a 3-inch? Simple. Everything's the same. Insulation, wire size. I want to know how many number 6 can I fit in a 3-inch. So what we do, and it's an EMT, number 3. Here's your 3-inch pipe. Go down. Number 6, we can fit 69 of them. 69 conductors you can fit of number 6 in a 3-inch conduit, having the same insulation type. Remember, again, Annex C. It has to be the same. So let's just say, how many compact conductors can I fit in electrical metallic tubing? Okay, so let me show you an image really quick of compact conductors. We see it a lot in feeders, just to save space, and we order aluminum, and it's just to compact the wire the most we can. Let me switch my camera really quick. Okay. Okay, here we go. And there it is. Now you can see it. It says compact stranding is a result of manufacturing process where each strand of the conductor is shaped to the intent that the space between the strands is virtually eliminated. So as you can see, all these conductors, they have been designed so they can interlace and fit tightly with one another. That's the purpose. It's just to reduce the space. Look at all this cuts that they have, all this fine design that they have in this wire. That's a compact wire. So in chapter 9, we are able to identify these, but we have to see that under the asterisk. Let's zoom in. Right here. So the C.1A with the asterisk, that's letting you know that that's for that compact wire. Here it is. Where this table is used in conjunction with table C1 to C13, the conductors installed must be of the compact type. And that's the asterisk. Let me take you really quick. See if I can quickly find it. I can't see it. Let me get my code book. No, I do have mine's highlighted. Okay, in note number 10, here it is. So the values of approximate conductor diameter and area shown in table 5 are based on the worst case scenario and indicate round concentric stranded conductors. That's just for your standard that we usually see daily. Let me zoom in a bit more. If I can move my screen. Okay, how do I do this? We're gonna have to just do what I have here. Okay, so round concentric lay stranded conductors, solid and round concentric stranded conductors. Okay, so indicate round concentric lay and stranded conductors, solid and round conductors. Values are grouped together for the purpose of table. Okay, here it is. Round compact stranded conductors values are shown in table 5A. When you see the round compact stranded, that's where you see your let me change my camera real quick. Round compact stranded. That's what it is here, compact. Here it is, compact conductors, chapter 9, table 5A. Alright, let's move on. So it's important for us to understand the first page, because if you can't get this page, you're not going to get far much down with formulas, with calculations of conduit sizing. Why? Because you never understood this section here. You'll be surprised how important it is to understand this chapter 9 tables. Right here you're getting the introduction for the nipples of 24-inch or less, the 60% fill. Like, ask yourself, where do you get the 60% fill on the code book? Well, you need to come to chapter 9, and it's right here. 60%. So where conduit or tubing, nipples having a maximum length not to exceed 24 inches are installed between boxes, cabinets, or similar enclosures, the nipples shall be permitted to be filled at 60% of cross-sectional area. Adjustment factors need not apply to this section. There you go. So let's just say your inspector just wants to see how much you can navigate through this code book, and he's asking you, well, where do we find this? Well, it's good to know where to point the, where to put your finger on the book and say, well, this is where it says, well, we have notes to the tables. Remember, it's not informational note, but these are notes to the tables, so we can use these as a 24-inch 60% fill. Remember, I want you to get this before I continue on, because if I go into the pipe sizing and you're going to get lost in what table we're looking at, the 60%, 40%, and I think it's the 31%. So just because we're used to the 40 and 60%, that doesn't mean that the test won't ask you for a 31% fill. So you have to be careful in how you approach the question. Okay, for, let's just say, table 1 applies for system and is not intended to apply to sections of conduit to be used to protect exposed wiring from physical damage. That's something else. This is just for a proper, complete install. That's what it's saying. Okay, equipment grounding and bonding conductors where installed shall be included when calculating conduit or tubing fill. The actual dimensions of equipment, grounding, or bonding conductors, insulated or bare, shall be used in the calculations. Okay, so you do have to remember, let's say we do have a bare wire. Well, what's the cross-sectional area for that? Because we need to consider that the CSA, cross-sectional area, for that particular wire. So how do you get that information? How do we get that information? And also, again, it's going to be in chapter 9. So what it's telling you on note 3 for the tables, it says equipment grounding or bonding conductors where installed shall be included when calculating. So if you are making the calculations, you have to consider the grounding wire, bare or with insulation. Insulated or bare, either way, you shall include it in your calculations. It's like I guess it speaks like the Bible, shall or shall not. So here we're looking at it. It shall be used in the calculation. So let's be aware of that. Where conduit or tubing, nipples having a maximum length not to exceed 24 inches are installed between boxes, cabinets, or similar enclosures, the nipple shall be permitted to be filled at 60% fill. Do you have to fill it up at 60%? No. It's going to be 60% or less. If you want to leave space for future wires, that's fine. But if you want to max out the fill, then you're limited with 60%. Okay, so let's move on to different tables. Remember, this is just the introduction, chapter 9 tables. This could take all day, but I'm trying to go as fast as I can. But again, I don't want to leave you behind where later on in the videos I'm looking for the percentages fills and then you're lost. Why? Because we ignored the tables on chapter 9, the introduction. Okay, let's go for fiber. For conductors not included in chapter 9, which is fiber, such as multi-conductor cables and optical fiber cables, the actual dimensions shall be used. So it is very important for you to see the CSA for fiber optic cables and, let's say, motor control cables, where it's already manufactured. It's already manufactured that way, where the wire has been sent to you and you have a cross-sectional area. If I was to do a takeoff on this, I would actually see the wire that is needed, try to get a CSA from the vendor, the cross-sectional area, or try to pull up the specs of that cable and do a takeoff for my pipe with that. You know, remember, this takes time, but again, if you want to be well prepared, you can get the cross-sectional area of your cable. It's just, you just got to get the information, but you're able to do so to do your takeoff. It makes you look really good whenever you are prepared and you're looking ahead of your work. Where, let's say your cable shows up and you're ready to pull wire and you have your conduit finished. Well, it's good to be with the right size. You don't want to be surprised where you know, your pipe is too tight. Then if you do get inspected, you can fail. Remember, the reason why we select the proper size conduit and, you know, demand factors is to avoid the heat buildup in the conductors. Remember, heat is the enemy of our wire. The more heat you got, the more resistance. The more resistance, the more amperage you got to push through to get that power from one end to the other, or information of signals from one end to the other. It's a signaling cable, fiber optic. So, well, the concern with fiber optic is, you know, the bends. There's a tolerance if what fiber optic can handle. It can't see too many bends. But that's the electrician's job, is to avoid any hazards in the future when this equipment or this signal wire can have a potential failure in the future, and now we're having breakers trip because it's too hot. The breaker's sensing too much heat. Because remember, the power wants to get there regardless what it has. So it's just going to draw more amps. If it's having a hard time, it's going to demand more amps to get that watts at the other end. So it's going to draw more heat. And that's the purpose of this code, is to avoid having too much heat buildup. We're okay with heat, but there's a limit for that. Okay, so let's move on to the conductors included as a multi-conductor cables and optical fiber cables. The actual dimensions shall be used. So what it's telling you, you need to get the CSA of your cable that you're going to install. Okay, let's go to note 6. And I'll read off the screen so y'all can follow along. Okay, for combination of conductors. Now this is a good one here. Sorry. Chapter 9, notes to table 6. This is the one that you're going to be using a lot throughout your installs. For combinations of conductors of different size, use actual dimensions, or table 5 and table 5A. Remember, table 5 and table 5A are the compact. For dimensions of conductors, and table 4 for the applicable conduit and tubing field. Okay, so now here we're getting two tables involved. So table 5, let me show you real quick. Where are we? Let me zoom out. This is here we go. Table 5. All this here. Let me just zoom in on one of these. Let me see THHN. Something that we're familiar with. Here we are. So THHN, this is table 5. Now what? Now what do we see? Okay, again. So let's go to the head of the table here where it says approximate area square inches. This here. Remember, we're not metric. Forget about this. Metric is no good here in America for our test. Square inches is what we use. Square inches. So these numbers here, like 0.0556, 0.0726, all this number here, this graph of this line here, That's what we're going to use. This is our American wire gauge wire size, or KC mil once we get to the larger side, 750 KC mil. So this is where people are going to get stuck. But again, you're just going to have to understand how this table marries the other one, which is table 4. This is table 5 right here, and table 4 is right above us, further up this way. Table 4 gives us the CSA, the space available inside the pipe. This here gives us the cross-sectional area of each wire. Okay, question. Let's just say how many TFFNs. I have 3 TFFNs. Let's just say number 16. And I have 4 THHN number 12. How many can I fit in a 1-inch conduit? Well, again, you're going to have to go to this table, table 5, approximate area. If I were you in your code book, I would highlight this. And just show you what I've done in my code book. Look at my camera. And I will switch over my camera really quick to show you what I do just to prepare for tests. Okay, so here I have THHW, and I just highlight that because it's just a standard a lot that I use. I highlight the American wire gauge, and this is for the size, and then approximate area, I highlight that also. I don't worry about this. I just completely ignore that because we're not testing under metric. So I've noticed, if you notice here, I kind of draw a line across my book to quickly reference, because remember, when you're testing, time is against you. So let's say the cross-sectional area for number 10 THHN or THWN or THWN-2. So what I would do, I'll circle my 10 because this is what I use a lot. So number 10 is skip this one because remember it's metric. We don't care about metric in this video. Now 0.0211 is what I'm going to use. That there is what I'm concerned about. We're not worried about approximate diameter, okay? We're worried about area. Remember, we're trying to get a conduit fill and we need to use cross-sectional area. Why do we need to use cross-sectional area of the wire? Because in chapter 9 tables told us to. For us to use the CSA of the conductor, let me show you really quick. Where are we? Okay, here you go. This is why we use that. For combination conductors of different size, use actual dimensions of table 5 for dimensions. When calculating the maximum number of conductors, here we go. When calculating the maximum number of conductors or cables permitted in a conduit or tubing, all of the same size, cross-sectional area, including insulation, the next higher step hole number shall be. Okay, so this is just allowing you, like if you want to go 0.5 and above. But we are using cross-sectional area. That's what we're using. That's what we're using. For conduit fill. So again, let me go back to table 5. I apologize if this video has prolonged, but again, this is my study. You can join me if you like. I'm just sharing what I study and things to get familiar with, because at the end you want to be a prepared electrician in the field. We don't want to make these mistakes where it's going to cost us time, money, and possibly your employment with the company. So here you go. Cross-sectional area, square inches, and this is all for us. You want to do 12. This is your concern here. Remember, ignore this. This is metric. This is cross-sectional area. Let's just say, okay, let's go another example. XHHW, we do see that too. So type KF.-1, KF2, and so on. Then we have these. XHHW, we do see that a lot. What's the CSA for this number 10? XHHW, it's going to be 0.0243. That number is going to be needed in the near future calculations. Okay, so again, this is just an introduction of what we're going to look into in the future videos. Now let's go to table 4. Don't fall asleep on me now. Go drink some coffee if you're falling asleep, and so you can wake up and understand what's being shared here. It's for free. So okay, so chapter 9, table 4, we're seeing different types of conduits or tubing. So here we see intermediate metal conduit, IMC, and you see all this over 2 wires, 1 wire, 2 wires, total area. So don't worry too much about that. We're going to select just a couple of them so we can slowly, gradually learn the understanding of these tables. Let's go to EMT. How about that? Here we go. Article 358. That's where you can get more information. Okay, Article 358, and it just extends to Chapter 9. So, electromagnetic tubing, EMT. What did we say about nipples earlier in the notes to the tables? 60% fill. This is your area here. 60%. Ignore this. Metric. We don't care about metric here in this video. 60% square inches. Then you get the internal space of the available space for your wire. See these dimensions and percent area of the conduit and tubing. Areas of conduit and tubing for the combinations of wires permitted in table 1, chapter 9. So this table recognizes the combinations of wires. So if we need to come up with a pipe size with different sizes of wire, different insulation types of wire, it's all good. You can take it to table 4. So the space available for the tray size, 1.25 inch, EMT, 1.25 inch. At 60%, I would highlight all this. From here, highlight this, because that's what you're going to use in your code testing. On your 2 inch, or we said 1.25 inch, right? It's going to be 0.897. Okay? Now, let's just say we only have 2 wires and you're testing, and it's really letting you know that you only have 2 wires, different size combinations, different insulation types. You can use 2 wires, 31%. You can use this chart here. Again, ignore the metric, because this 2 wire has metric and then square inches. We're using square inches. So for 1.25 inch for 2 wires, a different size at 31% fill, where you at? 0.464 available. Now, nominal internal diameter. That's just for your information. Nominal. We don't really mess with this. And then total area is the available space. Okay, and last but not least, the 40%. This table here, we use that a lot daily. This is for our branch circuits. We use 40%. Why? Because it's more than 24 inches and it's over 2 wires, so we stick to 40% fill. Again, this is not applying demand adjustment factors. Okay, adjustment factors is another thing. So let's just say more than 2 wires, 40% fill, we look at this table here. So for 1.25" at 40% fill is 0.598. That's what's available. Okay. Let's go ahead and dig into some of the material that we have for today. And I will be ending this video really soon.
Teach me your voice, so I wake up when you say hi. Start by saying hi. Now you can.
Sorry, Bixby is interrupting my video. So I will cover some of the answers the best I can with my pencil. Okay, so question. Let's switch cameras. Book cam. Okay, so here, I want you to see what's the cross-sectional area of 110 THHN conductor. Question. What's the cross-sectional area, CSA? We're going to start using CSA as a shorter term to read it. What's the CSA area of 1 THHN conductor? Okay? So, if you notice, it gave you the size of wire, it's the type of insulation, and how many. It's asking you for the cross-sectional area. These are key words that you need to pay attention to. So what we do, let me go up to my code book and I'll leave that screen running. What's the CSA? THHN number 10. One wire is just CSA. Remember, the tables in table 5, it's going to be 0.0211. So we see here the area of 1 THN, number 10 THW dash 2 is 0.0211 square inch. This will be your answer here. That's your CSA, cross-sectional area. It's the whole width of this wire. That's what we're worried about. The whole thing, the width of this wire, because we're doing some pipe fill, and we want to include everything that's of that wire, again, to stay in the 40% fill or 60% or 2 wires, and be able to come up with our conduit size. Okay, the next question would be, again, I don't hold the copyrights to this book, but this is my study and I'm showing what I study. Now I'll read you this question. Okay, what's the area for the area of a 8 THWN-2? So what's the CSA for a number 8? THWN-2. Let me take you to the YouTube share. Let's go to table 5. Okay, let me search it faster. Table 5. That's table 4, table 5. THWN. Here we are. But remember the asterisk? So we want to avoid that. THWN-2. Here we are. So THWN-2, remember all these 3 are included in this table. And for number 8. For number 8, CSA 0.0366. So as we can see, let's switch cameras here. 0.0366. So that's our CSA for this wire. Remember, I'm slowly introducing you to this. So on the next video, we're going to do some questions to see if you can really understand how to do pipe fill. It's not good to have these apps on your phone and try to rely on that. Remember, if you want to prepare for your test, you need to learn how to manually search your answer. For number 8 is 0366. That's your answer here for THWN-2. Okay, let's do a different type of insulation. So book cam. Okay, here we go. So table 5, what's the without an outer cover example? Okay, so RHH, that's the insulation type, without an outer cover example. What's their CSA of 1TH10? RHH. Without an outer cover. What does it mean without an outer cover? Okay, so when we step into RHH, there are wires where they have a protection, and we have to take note of that. Without an outer cover. Let's go back to our okay. Thank you. Okay, let's go to the last of table 5. Last of table 5. Again, I apologize for the length of this video. It's just really intensive material that we could cover, and it's just so much that we need to learn on these tables. Okay, so in table 5, the last of it, chapter 9, table 5, we do have this little asterisk. It says types RHH, RHW, and RHW-2 without outer covering. Without outer covering. So if this question here is asking us, let's switch the camera. What's the cross-sectional area of 110 RHH conductor without an outer cover? Then we have to search the insulation type with this asterisk next to it. Why? Because this information here is letting us know which category of wire it falls in. So we need to go up here, and there they are, without. You see this RHH, RHW, RHW-2, and the asterisk? That means is without the insulation coverage. So the question is asking us what size of number 10 RHW without an outer cover. RHW-2, number 10. So we got to go up. RHW-2 number 10. Remember, that's your wire size, approximate area. So we're going to study this table here. It's 0.0333. So let's go to our question. Okay, so our question is, what's the, without the outer cover? So our answer is 0.0333 square inch. Remember, square inch. This is without an outer cover is 0.0333. How do we come up with that? We go to our code or our tables. We saw the note, the information of the asterisk. We went here. This is your wire size, and this is your square CSA for area for in inches, square inches. And it's 0.0333 for number 10, RHW-2 without an outer cover because the asterisk. Remember, the asterisk is the one that sets the rule. So again, this is just an introduction of chapter 9. There's much more that we can do with this table, but it hasn't changed much because it has a lot of the standard calculations that we use in the field. And what I would do, I would practice on this table. There's free questions online, free material, other videos where you can learn more of this table, and it's going to follow you in every decision you make as a leadman, even if you're an apprentice. Learning how to make this choices, how you came up with your answer is really good. Journeyman's out there also making the decisions and jobs, what size of pipe we're needing to install. It's really good to get familiar with this table here in this chapter 9, where you're able to come up with your answer and ask questions too before you do the takeoff and avoid any hiccups down the road on your jobs. So there's more to this table. I guess on my next video I would do more questions. I'll try to prepare questions during the stream so that we can see whenever how many conductors. For example, let me just give you one insight really quick. Let me switch really quick. Okay, here's a perfect example. So a lot of us will start, let's say here, automatically we see either, what is this, disconnect or circuit breaker to disconnect the main. This seems like your service. Well, anyways, two things that should stand out really quick is the nipple right here where it's less than 24 inches. From this edge to this edge is less than 24 inches. Now, we know that we can use, we can save up, we can use more of the CSA of the pipe than your 40% fill. Okay? So here it's letting us know it's a PVC schedule 40. Okay? This is important here, schedule 40. Remember how we, let me see, how we saw the table 4. I'll take you there really quick. Where's PVC, RNC, PVC, schedule 80, schedule 40. Here we go. So let me, if you can see this, schedule 40. We're at 60%. Remember, then trade size. I think it said. I guess it's asking us what size of pipe. Okay, So on your test, you will see this information that'll tell you, hey, you have a PVC Schedule 40, and you're going to have these conductors going through it. You're going to have 3 500 kc mills. Again, the insulation type, it's important to know. The size of wire and how many. Number 1, 250 kc mill, insulation type, and 1, number 3, American wire gauge for your grounding. So it makes sense, right? So they're giving you pretty much the description what you're going to install. All this information here, you're going to have to take that to tables 4 and 5 to get your information. Table 5 will give you the CSA of each conductor. Let's just say for the 500, so square inch area in square inches of conductors. Chapter 9, table 5 says the 500 THWN-2, that's your installation type, wire size. What's the CSA on this table? It's 0.7073 square inches. How many do you have? 3. So you're going to get the 3, multiply that, you get the 2.1219 square inch for this one. So we still have 2 more to go. We have 1 250 kc mill, installation type, THWN-2. We're just going to add that one. So here is just, how do we get this number? In table 5, 0.3970, we're just going to add it to the formula. Now the number 3, THWN-2, 0.0973, how many of those? Just 1. You add it to the formula. We add all this, and we're going to get the total area of the conductors is 2.6162 square inches. Now remember that rule earlier in the notes where it says number 7. Let me just take you there really quick. Note number 7, I'll just read it to you. When calculating the maximum number of conductors or cables permitted in a conduit or tubing, all of the same size, total cross-sectional area including insulation, and the next higher whole number shall be used to determine the maximum number of conductors permitted when the calculation results in a decimal greater than a 0.8. When calculating the size for conduit tubing permitted in a single conductor or calculation results in decimal greater than point or equal to 0.8. Mix myself up. So we want to look for a pipe that is 2.6162 or greater to stay within the 60%. Okay? So we go to chapter 9, table 1, note 4, and we look up for tray size. Let me take you there. Let me write that down. Oh, I can see it here. So come on, zoom in, buddy. So it's PVC. It's PVC, and we want to look for 60% fill. So we want to stay on this area, and we want to stay above 2.61. I always look at the first three numbers, 2.61. So here it's between, so we fall in between a 2-inch and a 2.5. A 2-inch having at 60% fill. The 2-inch available is 1.975. So obviously that's too small. So we need to go to the next higher size. So the next one will be a 2.5, having available of 2.817. But we're at 2.61. So that means we have more available space. We're within tolerance of the 2.817. We cannot exceed that. If we exceed that, then we got to go to the next size. Okay? So we can't stick around with this size of pipe if we do not if we exceeding this 2.8. So we're at 2.617. So we're just right underneath this 2.8. 2.817. So we're good with a 2.5. And that will be your answer on your test. It'll be 2.5 PVC Schedule 40. Remember, it's important to define Schedule 40 and Schedule 80. Because Schedule 40 required at 2.817 square inch. That's what's available for that pipe. Again, in the field, if you are, let's just say you got a pretty long distance, 400 feet or something, a feet underground, 300 feet, it can happen. You might want to size this a little bit higher just to avoid any, you know, you don't want to be pulling at, well, never mind that. That's a 60% fill. I thought we were at 40%. But yes, at 60% fill, it's less than 24 inches. That's the rule that we're able to use. And we're able to select our size for these feeders. And we should be good. So I hope this channel is able to help you in some of the stuff you're looking for. I will try my best to title it and narrow more on these videos, where if you're wanting a little bit of review for chapter 9 or articles 300 wiring methods or 210 or definitions, I will try to just kind of narrow it down. Pretty soon I will try to make videos on motors, on sizing motors, multiple motors, starters, overcurrent protection for those, the heaters, sizing them, getting the FLA for your wire, all that stuff that's needed in the field for motors. That's one of my favorite subjects, motors. I do enjoy just checking what engineers do design. I also enjoy just, challenging myself whenever I'm in the field, just looking for FLA on motors. But again, I might have an audience, a Spanish audience, so I may have videos in Spanish in the future if I get an audience that's looking for that. If I don't, then I'm not going to go there because I don't have a Spanish code book. But if I do notice that people are wanting, let's just say they wanted certain subjects covered or articles covered in Spanish, then I'm okay with that. I just need to get a good, at least more than 10 people requesting it, where it's worth the time, because again, this is my journey to the masters. I'm studying for my masters, and if I do make a video in Spanish, and I want to be something that the people are needing it, just in case they're having trouble with certain things out in the field, and I can help clarify what they're needing help with. And again, if I don't know the knowledge, I'm willing to find where someone can help me get the right answer and share it to you. Again, if this video has been helpful, don't forget to like and subscribe if you are new, and also turn on your notifications to see the next video coming up. And hopefully y'all can share me in the fields. If somebody's needing help, just share my channel. Hopefully this can help them, and I know I will be getting better at my videos again. This is my first one. Again, you can dig into this material so much and time just flies by. I remember in class we just waste a lot of time on certain things, but again, I would learn, and for me it never bothered me to learn stuff that I was interested in. Electrical is my career, and I am interested to learn more about it and also share at the same time. I'm guessing there's a good proverb: the more you study, the more you share, the more you teach, you also grow. And I just want to also teach whatever I know. So I will be ending this video. And thank you for also, I guess, trying to stick along. If this video was too long, it doesn't hurt my feelings if you just go through it quickly and find what you need and move to the next one. But thank you for tuning in, and hopefully we can continue to make more videos out of this. So again, this is for the NEC 2020, and we're looking forward to seeing you in the future. So thank you.